Hello everyone, welcome to Economics Pedia and welcome to the second part of the difference and differential equations. So as in the first part, as you have seen, that we have covered the whole theory and the concept of for the differential equation. Well, the same thing we are going to do in this session for the difference equation. Now the importance of this chapter, that is the difference and differential equation, I have already mentioned in the first part. If you want to go, you can find below in the description box the link of the part 1, or you can also click on this card as you can see on your screen. So in this session we are going to solve the difference equation, both the first order as well as the second order difference equation. So let's start without any further ado. So starting with the first order difference equation, the equation somewhat looks like this, that is yt plus 1 at the suffix plus of a1 yt at the suffix is equal to b. This is equation number 1 we have considered. So this is the first order difference equation, but again it is non-homogeneous because of the presence of this b term, right? So now here also the basic objective of this whole dynamic chapter remains the same, that is we ultimately need to comment on the time path, that is how the system is changing due to this changes in the time period, right? So this is the basic objective of this. Again, we ultimately need to find the general solution, and for the general solution we need to find the two solutions, that is one is particular integral and another is complementary functions. Now particular integral, it is a solution which provides us with the intertemporal equilibrium of the system. That is, intertemporal equilibrium means that is the stationary equilibrium. That is, in the particular integral we don't consider the changes in the time period. Okay, so that is why it is the intertemporal equilibrium. Whereas in the complementary function, it provides us with the dynamic evolution of this system over time. Dynamic evolution. So dynamic word is coming due to changes in the time period over time, right? So this is the main difference between the particular integral and the complementary function. Now I am going to write in very short form the particular integral as pi and the complementary function as cf. Okay, I hope you can follow. So let's try to find the particular integral first. What you need to concentrate in here is that the way of obtaining the particular integral for the difference equation and how it is different from the differential equation. Okay, so keep your eyes wide open. So for the particular integral, here as I have said that it provides us with the stationary solution, right? So here yt plus 1 equal to yp. This is what we are going to consider here. This is the main difference. In the differential equation you will find that we have done it in a bit different way. So keep a tab on this difference. Okay, so because of this, what our equation 1 becomes is that yp plus a1 yp is equal to b, and that is why we have this yp is equal to b divided by 1 plus of a1, right? So this is the particular integral that we have obtained. Let this be equation number 2, right? Now it's time for the complementary function, that I am going to substitute as cf. Alright. Now there are some rules while solving for the complementary function. The rules remains the same both for the difference and for the differential equation. Rule number one is that we need to consider only the homogeneous part. So for the complementary function, our equation 1 becomes somewhat like this, and let me mark it as equation number 1 prime. That is, we are replacing the b term, that is whatever on the right hand side of the equation we are replacing it with the 0. That's how we have a homogeneous equation, right? So this is the first condition, and the second condition is that we need to consider a trial solution. So here the trial solution is again somewhat different what we have considered for the differential equation. So here the trial solution is a into b to the power of t. Okay, I hope you can see it very clearly. A into b to the power t. Okay, and what is the value of y t plus 1? It will be equal to a b to the power t plus 1. This is together, right? Now all we have to do is substitute these two values in equation number 1 prime. Okay, after substituting the value, we are getting the equation 1 prime to look like this, right? Now all we have to do here, again same as the differential equation, that we need to find the value of b in this from this equation. So let's solve it. A into b to the power t, b plus of a1 equal to 0. So here the value of b is equal to a1. Since we know that a into b to the power 3, which is our trial solution, cannot be equal to 0. Okay, so this is the value. And as I have also mentioned in part 1, that this is the condition of stability also, right? We need to have the value of the obtained root to be equal, to be lesser than the positive, that is lesser than the unity. That is the condition for the stability. And if you want to know that how this is the condition for stability, let us know by writing below in the comment section that you want to know the conditions for stability in this particular step. Okay, now moving on. So this is, we have found the value of b. So the complementary function, that is the value of the trial solution, we have to substitute the value of b in trial solution, that with what we have obtained. So our complementary function is a minus a to the power of t. This is the complementary function. So how the general solution would look like? So the general solution is the summation of yp and yc. What is yp? It was equal to b divided by what is yp? b divided by 1 plus a1 plus of what is yc? That is the complementary function that we have just obtained. That is this thing, a minus a whole to the power of t. Now, if we want to finally comment on the time path, we also need to find the value of this capital A. Now for that, we will be considering the initial time path, that is let time, that is t equal to 0. So this is the value of y0 or y0 and b 1 plus a into capital A, because this whole thing becomes 0. So from here we can find the value of a as y0 minus b by 1 plus of a1. This is the value of a, and therefore we can finally comment on this general solution by substituting the value of capital A as this. So what is capital A? Capital A is this thing, y0 b 1 plus a1 minus a1 to the power of t. Okay, so this big box, I hope you can see, is the time path, or this equation is going to provide the time path for the system that we have considered initially. Okay, so this is the solution of first order difference equation. Now let's move towards the second order difference equation. So let's start with the second order difference equation. The equation somewhat looks like this, that is yt plus 2 at the suffix plus of a1 yt plus 1 plus a2 yt equal to b. So this equation number 1 is the second order non-homogeneous difference equation. So ultimately the objective remains the same, that is we need to comment on the time path. So let's start by solving the particular integral. Now the particular integral provides us with the intertemporal solution. That's right, the stationary solution. So for that, we will be considering yt plus 2 to be equal to yt plus 1, which will be equal to yt and ultimately equal to yp. Okay, so this is the thing that we require, and if we substitute this whole thing in equation number 1, what do we get? Let me take it as common. So here we will be getting y1 plus of y2, this will be equal to b, right? And we ultimately need to find the value of this yp because this is the particular integral, and this is equal to b by of 1 plus a1, 1 plus a2. Okay? So this is the particular integral solution. Let me mark it as equation number 2. Right? Or let's do one thing. Let me consider this equation number as C. Okay? Why I am doing it? C. Why I am doing this? Because many of you must be thinking that in the first order difference equation, I have written the equation, the non-homogeneous part was equal to B, and in the trial solution also I have considered a B, right? So let me tell you that these two B's are not the same. It is different. The trial solution B is completely different from the original equation B. Okay, as I am just considering the general format of the equations with the help of some variables, arbitrary variables, so it might raise a question in your mind related to this. So here is the clarification that the two B's are completely different, and that is why I am considering the equation to look like C. Okay, so C is the non-homogeneous part, and therefore this is the particular integral that we have obtained. Right? So C divided by 1 plus a1 plus of a2. Let's move towards the complementary function. Okay, so what is the rule number 1 for the complementary function? That we need to consider the homogeneous part. So let me make this C as equal to 0 and mark it as equation number 1 prime. Okay, so the homogeneous part we need to consider. What is the second condition? The trial solution. So here also the trial solution remains the same that we had considered in the first order difference equation. Okay, so that is yt equal to a b to the power t. Now, what will be the value of yt plus 1? It will be equal to a b to the power t plus 1, and similarly it will be equal to a b to the power t plus 2, right? So let's substitute these values of yt plus 1 and yt plus 2 in equation number 1 prime, and let's see what we obtain. So this is what we obtain after substituting the values. Again, we need to solve the value of b, so let's do it. Here we have b square, a1b and a2. So ultimately what do we have? It's b square a1b plus of a2. This is equal to 0. Why? Because our trial solution cannot be equal to 0. So this is what? This particular thing is what? It is a quadratic equation, right? So we ultimately need to solve it with the help of Sridharacharya's formula. And as it is a quadratic equation, we will be getting the two values of b for here. What is b? b is the value of the trial solution. Here, the value of b. So let's apply the value. Let's apply Sridharacharya's formula and let's see what we obtain. So here we have minus a1 plus minus of root over a1 square minus of 4a2 divided by 2, right? So this is the whole thing. Now, since we have a quadratic equation and since we have this format of b1 and b2 towards the solution, the ultimate value of the roots depends upon the value of the discriminant. What is discriminant? That is root over of a1 square minus of 4a2. On the basis of this, we finally going to obtain the complementary functions. There will be 3 different complementary functions and 3 different general solutions. So keep following. The discriminant value is this thing, a1 square minus of 4a2, right? This is the value of discriminant. Now this whole thing can be either greater than, equal to or less than 0. So that is why I have mentioned that there will be 3 complementary functions. Starting with, let's say, greater than 0 situation. Here we are going to have the roots. The 2 roots will be real and unequal. That means unique roots we will be getting here. So real as well as unique. Okay. So in this case, the complementary function would look like a1 b to the power t, b1 to the power t, plus of a2 b2 to the power t. b1 and b2 here are different. Okay. So this is the case 1. Let's move to case 2. Case 2 says what will be the value of the complementary function if we have the value of discriminant equal to 0. So here the value of the roots, that is b1 and b2, they will be real, but here they will be equal. That means repetitive. It is not that we are going to get a unique value of the roots. So here we are going to get it as real and repetitive. Okay, that is what I mean by repetitive is b1 and b2 will be equal. Okay, so under this case the complementary function is a1 a2 to into t whole to the power b to the power of t. So here this b is equal to b1 and b2, and these all are similar since we have this repetitive value of the roots. Okay. Now finally we are good to move towards the third case. That is what will happen if the value of discriminant is less than 0. If it is less than 0, then what will happen to the roots? It will be imaginary. It will no more be real. The values will be imaginary, and rather we can also say it will be complex conjugates. Complex conjugates. That means it will moreover look somewhat like this, h plus minus iv. So h is the real part and iv is the imaginary part. Here the complementary function would somewhat look like a1 into h plus iv to the power t plus of a2 h minus iv to the power of t. However, this is the format that we don't generally use in our solution process. The one that we use is look somewhat like this, r to the power t a3 into cos theta t plus of a4 into sine theta t. Alright, so this is the format that we generally use in order to have a comment on the time path scenario of the given equation. Alright, now from this equation to this equation, how we obtain this is a small derivation for it. There is a small derivation for it, and if any one of you is interested to know about this derivation, please let us know by commenting in the comment section that you want to know the derivation of this two equations that we have obtained for the complex conjugates. Okay, and after this all we have to do is that we need to obtain the general solution. We have already obtained the particular solution in case of second order difference equation, right? And on the basis of this discriminant, the value of the discriminant, we are going to obtain our complementary functions as well. So once we put them together, we will always be easily able to obtain the general solution. Now let me give you a very important analysis of the time path related to time path, is that in the case of this complex conjugate, that is when we have the value of this discriminant lesser than 0, then in this case the time path will always be oscillatory, right? Why? Because of this cos and sine, and these are already in the oscillatory motion, so we can easily say that this will be oscillatory time path they will be following. But these oscillations, whether they are damped or diverging, that will depend on the value of this capital R. Okay. So this is all about how to solve the difference equation, and we have covered both the first order as well as the second order difference equation, and in a great details we have discussed it. I hope you have understood all these theories in a much clearer and in a better way. And if you have still any problem related to any of these sections or from the first part of this difference and differential equation, please don't hesitate to let us know by either writing below in the comment section, or you can also straightforward mail us to our official mail ID, that is ecopedia02@gmail.com. So stay tuned to Economics Pedia, and if you have any kind of further queries or doubt related to economics area, and if you want to know how the pattern that we are following in order to teach the students and prepare them for the competitives, please feel free to contact us by mailing us into our official mail ID, that is ecopedia02@gmail.com. Thank you for watching this. See you in the next video, and we'll be there with some new interesting topics from economics. Stay tuned to Economics Pedia.